Hi, I'm Dr. Younger, and I'm director of the Neuroinflammation, Pain, and Fatigue Lab. So, most of the work I do is on treatments for chronic pain, fatigue, and cognitive disorders, things like fibromyalgia, myalgic encephalomyelitis, chronic fatigue syndrome, long COVID, Gulf War illness. And I take a lot of different approaches to combating these disorders. So, I do pharmaceutical work, so looking for new drugs. I do botanical work, supplements, and also interventional treatments like vagus nerve stimulation or brain cooling. But there's one thing that ties together all of these different approaches, and that is the microglia. If you've been listening to my talks, you've heard me mention these before, but I wanted to talk about them a little more in depth in this video. I thought it was a good time. So I want to tell you what I'm trying to do when I talk about we need to modulate the microglia, and I want to give you the nomenclature that I use. So when you watch the future videos, when I talk about specifically how we're trying to do this, you'll know what I'm talking about. So let me tell you the story about why I'm even talking about microglia. Why do I think they're so important? So when I was a postdoc in, let's say around 2005 in Arizona, I was working on fibromyalgia. And a lot of us were trying to figure out what in the world is going on with fibromyalgia, this chronic pain thing. There doesn't seem to be anything wrong with the body, but they hurt all over. Now, by that time, about 2005, we'd pretty much figured out that the problem with fibromyalgia is in the central nervous system. It's not actually in the body where you feel the pain. It's actually in the spinal cord and or in the brain. So it's a central nervous system problem. The issue is we couldn't figure out what in the central nervous system was actually dysregulated. So we had some groups looking at serotonin, some groups were looking at dopamine, some were looking at glutamine or glutamate, most often glutamate, and then some groups were looking at opioid dysregulation. And I was one of the ones looking at opioid dysregulation. So we're all looking at these different neuronal types and different neurotransmitters, and there were interesting things for sure, but there was something missing. There was clearly a missing piece. What we were finding was not explaining what we were seeing, and the condition wasn't responding to the drugs that you would expect if these neurotransmitters were dysregulated. And so something was missing, and that's what was really bugging me kind of during this time. So I'm sitting at my desk one day, and a big fat paper just gets plopped down in front of me in the desk. And I looked up, and it was one of my mentors at the time, John Rich at Arizona State University. And he just said, "You need to read this." So I picked up the paper, and it was called Glia as the Bad Guys. And it was written by Linda Watkins and Mark Hutchinson and their colleagues who I've mentioned before. And the short story was that this was the missing piece that I had been looking for. Now, finally, things started to make sense. And the major shift was we've been looking at neurons this whole time, but it wasn't the neurons that was the problem. It was the microglia. The neurons in our brain are just transmission lines. They're just sending messages. The microglia are what are in control of everything. So everywhere there's a neuron, there are microglia reaching out and touching the neurons and touching the synapses and controlling what the neurons do and what happens at the synapses. They can modulate the neurons. They can destroy a neuron if they want. They can prune back the synapses. They can change the way the neuron responds to neurotransmitters. And so all this attention we gave to neurons, while they're very important, like you have to have neurons to transmit messages, it's actually the microglia that are changing things. And so when there's a problem occurring, it is more likely to be due to the microglia adopting a pathological state. And so what I realized after reading this paper, and I'll put a link to it. It's probably open access by now. I'll put a link in the description in case you want to look at it. It's a long paper, but it's very, very interesting and a pivotal paper. And so what I realized is that we can't win against fibromyalgia by going after the neurons. We have to go after the microglia. And this is a very different approach than was conventional because all of the treatments were about neurotransmitters. They were looking at serotonin and norepinephrine, things like that. And what I realized is that's not going to work. If the microglia aren't in the right state, it doesn't matter what else we do. So we have to push the microglia out of the pathologic state and into the state that we want, that returns a normal state. So there's no more pain and fatigue and cognitive problems. So let me tell you what that means. Basically, the microglia, as I mentioned, they're cells, and they're everywhere you find your neurons, and they're controlling everything. Now, the interesting thing about the microglia is they can change states very rapidly, at least within a few minutes. And in some cases, I've seen evidence that they can change in a few seconds, but we'll say generally in a few minutes. So quite rapidly, they can change their shape very considerably. And when they change their state or their form, they have a different function, radically different functions. And so I'm going to draw while I talk and demonstrate what I am talking about. So there are 4 states of microglia that we're chiefly concerned with. There are other states, but there's only 4 that we're going to talk about now that are most important. So the first one is the resting or quiescent state. And there are other names for it, but I'm just going to call it resting. And this state is also called the M0 state. And in the M0 or the resting state, the microglia they're doing things. They're not truly resting, but they're not causing inflammation in your brain, and they're not actively combating inflammation or immune triggers. They're basically doing kind of a house cleaning functions and support functions. And this is where you want your microglia most of the time. They're looking for problems, they're surveilling the environment, but they're not making huge changes to the environment. And so when your microglia are in this state, you probably feel pretty normal. This would be the normal state for a healthy individual. So then there's the activated state. And the activated state is also called the M1 state. And when the microglia are in the activated state, they produce pro-inflammatory cytokines. And these cytokines cause your symptoms, whether it's fatigue or pain sensitivity or cognitive problems or malaise, dysphoria. It's being caused by these cytokines released by the microglia in the brain. So these microglia can move back and forth between resting and the M1 activated state. But there's another form of the microglia, which is anti-inflammatory, or the alternative state. And we also shorthand call this the M2 state. Now, in this state, it looks kind of similar to the M1, but it's doing a very different thing. Instead of pumping out pro-inflammatory cytokines, pro-inflammatory agents, it's pumping out anti-inflammatory agents. And so if your microglia are in the M2 state, they're going to be calming down inflammation in your brain, in your central nervous system. And the microglia can also move back and forth between resting state and the M2 state, as well as they can move between the M2 and the M1 state. So that's 3 big states. Now there's a 4th one, and that's the primed or hypersensitive state. The microglia, when they're in the primed state, are operating on a hair trigger. They're ready to activate with very little stimulus. And so they can move, they can be pushed from the primed state very readily, very easily. They can be pushed into the activated state. And so your microglia start to react to things in your environment, in your internal environment, that they normally wouldn't react to. So they're very, very sensitive. So you've got moving between primed and M1 very quickly. So what do we need to do? Well, obviously, I believe that if you have these conditions I mentioned, like chronic fatigue, like fibromyalgia, like long COVID, like Gulf War illness, your microglia too many of your microglia are in the primed state, or too many of them are in the activated state. And we have to change that if you're going to feel better. So we have to move the microglia back to the M0 state, the resting state, or we need to push them to the M2 anti-inflammatory state. And every treatment that I try is designed to do that. I'm trying to return microglia to resting and keep them in that state so you feel normal and you feel healthy. And we do that by changing the microglia so we reduce the inflammatory agents that are being released in your brain. And that will calm down the pain, the fatigue, the cognitive disruption, and all the other things. So how do we do that? Well, that's a topic of other videos. There are many different targets on the microglia, direct and indirect, that could accomplish what we're trying to accomplish with them. There's also many different approaches. As I mentioned at the first of this video, there's pharmaceutical, there's botanical, there's interventional, there's also behavioral. So just learning what to avoid to keep from aggravating the microglia might be enough in some cases to get rid of a lot of these symptoms. So there are probably hundreds of possibilities. And as I've said before in previous videos, my job is to try to figure out what are the most promising approaches and then develop them and test them. So in the future videos, I'm going to be covering a lot of these treatment options. That's what I do. So that's what I'm going to talk about. So do keep an eye out every Monday, and I will continue to talk about my attempts to modulate the microglia and talk about which ones I think are most likely to turn into effective treatments. So do stay tuned. Feel free to post your questions below if you want. I'm in the middle of a pretty brutal grant writing session. It's going to take about 4 more weeks, but I'm still going to look through all the questions and I'll spend as much time as I can answering them. So thank you for listening, and I hope to see you here soon.